So we'll talk about defining terminologies, how we can use that to validate your data, how all of this kind of contributes to aiding you have contextual metadata a bit more easily. But to begin, it all revolves around the term set. So the term set class provides a way for users to create their own set of terms, whether it's from a brain atlas, species taxonomies, an assortment of ontologies. And term set is built upon resources from LinkML. And that's a modeling language that uses YAML-based schemas. And doing so really gives us a good structure, but also a variety of tools that we kind of take advantage of. So here we have the schema of a term set. And from this, you would have your ID, your name that you're going to give it. The prefix is very important. And so in this example, we have one, and this is essentially the resource that you are referring to. So just kind of move along for a second. I'll get back to that. We have enumerations. So these are all the permissible values, in this case for species. So if someone comes along and says, hey, now, what is a Homo sapiens? They can read the description, but more formally, they have this meaning right here. And notice that this is the same prefix as over yonder. And so this meaning is the ID according to this resource. And what happens in the background for you is that this URI is merged with this ID, and it gives you a valid link to go to learn about what is indeed a Homo sapiens. So now, if you see here, there's only 4 of them, and I did that manually. It's not that bad. But things scale, and manual doesn't really work when you have 20 of them. I mean, you could get a grad student to do it, but that's not that fun. So you have 2 options for you. You have schema sheets. This really kind of embraces the idea that there are labs out there who have a lot of information stored on spreadsheets. Now, what schema sheets will do is it will take your spreadsheets and it'll create your term set or your LinkML schema here. Now, when I say that, I don't mean it'll take any old spreadsheet of any format. There is actually a formal way to kind of structure your spreadsheets. So I think it would be easier for if you have yours, you can kind of adapt it to the structure that LinkML kind of expects. Another option would be dynamic enumerations. This would be my preferred method. And so here you would have LinkML really supports multiple remote resources that you can kind of tap into. So the Obo Foundry would be one of them. And it houses, ontologies from all sorts of unique biological domains. In this example here, we have a user, would write this section here, my ID, my name, the prefixes that I want to use, so the sources. And then this is a little nugget right here. So I have my reachable from, so this would be my source ontology. In this example, it would be the Obo Foundry, and then the source node. So this would be important. This essentially says, from this node on, I want to be my enumeration. I want those to be my permissible values here. And I can either include myself, yes or no, for that node. Because we're using LinkML, they have a whole assortment of other tools, classes, and slots. These are optional. I suggest checking out LinkML to see how they work and how they can be used for your use cases. So I have this commented out because it gets really long, but let's see what it looks like. I mean, that's really nice. And so what this will do is it actually doesn't replace this term set. It'll create a new one alongside it. But yeah, that would be one long weekend to kind of type all these out manually. So thankfully, you do not have to. Great. So what do we have so far? We have our term set, and it sets a controlled vocabulary or permissible values, right? And also defines what are resources that we're using for this vocabulary. So now we get to the tools of term set wrapper, and this allows you to directly validate your data or metadata by wrapping the value of whatever the field is. And those values are compared to terms in the term set itself, and that's the validation, so term level. In this case, in this example, we have 3 term sets, one for experimenter, one for location, so brain area, and then one for species. Give me a second here. Now, there's nothing stopping you from having just one large term set that, houses everything. But I highly recommend that you don't do that. And so in this example here, you can have multiple prefixes. So with species, you can have NCBI, or you can have NCBI plus another one, another taxonomy that you want to use. The world's your oyster. So you create an NWB file. You've probably seen this a lot in the last few days, but what's different is here. You have your term set wrapper. And what this will do, it'll look at this list here, and it says, is Oliver Rubel in my experimenter term set? Yes or no. Is Ryan Lee is? Yes or no. And what you'll see, okay, give me a second here. There we go. You see the experimenter itself is in a term set wrapper, and if you wanted to access it, you would just do dot value. There it is. Subject, so you can have now this term set wrapper here, and using this term set specifically for species, you would wrap it, and you would see that it is also will be a term set wrapper. A more sophisticated example would be, let's say you have an electrode group, and you have your location, so your brain area, and your value would be amygdala for whatever reason, and then you would have your term set that have all your brain regions for you. Now, all that is manual in the sense that I or you would have to wrap it every single time. So let's say you really love the idea of having your species always being validated, well, then you would have to type a term set wrapper every single time. Or you could take advantage of a tool that we're going to talk about right now. And so this really revolves around something called a type configurator. You do not have to deal with that. But what you do need to deal with, or you get to kind of design yourself, is a configuration schema. And the format is as follows. And this is our introduction, bare bones, developer curated example here that will expand over time. But it goes as follows. You have your namespace. What namespace are you in? Well, core, because we're going to use the core namespace in PineWB. We recently did a release, so we're at version 2.7.0. And then you define, well, what data types do you want? So I want to say that for subject species, I always, to the end of time, want a term set associated with it. So subject is my data type, species is my field, and I'm saying term set, use this one. Now, if you're asking, why not just say species is equal to this term set here? That's a very specific question, but good job. This is set up for future expansion. So right now it's just used for term set, but maybe down the line, through collaborations with you guys, we can have multiple formats that we want to configure here. That's not just term set. So future proofing, if you will. Now, having this, creating it, why is my frozen? Okay, there we go. Having this here is only step 1. You need to load it. And so load your configuration. All right, great. And this happens because I've already loaded it. And so if I unload and then load it again, hey, it works. Okay, great. That just goes to show, don't load the same configuration file twice. It'll give you a warning saying, hey, this has already been loaded. Or I guess it'll give you an error that it's already been loaded. So keep aware of that. You can just unload it or just load it again. So in this example, we have our NWB file. We've loaded our configuration. And now our subject looks as it does in the standard tutorial. It's just Homo sapiens. So if I create this file and I do this one right here, what is it going to be? It is a wrapper. And that's all handled for you automatically. So you do not have to actually say term set wrapper as long as the configuration file is loaded, right? Now, whether you use the configuration file or whether you wrap it manually, it doesn't interfere with writing your NWB file. So it's just written per usual. What happens under the hood is it gets resolved for you. But where does it all go? So we have valid data, but what if we take advantage of having these be populating for herd? So what is herd? So to have fair data ecosystem that supports data reuse, herd is a toolkit of standardized methods. It's also a data structure here to create and manage linkages between data terms to an external resource. So in this example, I have a file. This is the ID for the file. In there, I have my subject, and subject is species. For some reason, I'm experimenting on human beings, so my key is Homo sapiens, and I might want to actually define what Homo sapiens according to this taxonomy, NCBI, right? So all of this information is actually stored in the term set for you. So what this will do is for everything you wrap, whether it's through the manually or through the configuration file, it will create a herd and it will a herd instance and it will populate it for you. Now, one thing I will stress is that herd is not inside the NWB file, and there's a really big reason for that. Say later down the line you want to update this. You had a falling out with NCBI for some reason and you want to use a different resource. You can change this directly using the tools within herd and then rewrite the herd file itself. And that would take a lot of time if you had to rewrite the entire NWB file to make this really small change. So that's why they're written separately. If you have any more questions about this functionality, future functionality, I'll be around for the rest of the session.